Example number 4. Let us now consider the following frequency distribution table which gives the weights of 38 students of a class. We can see the first column gives us the weights in kilograms and the second column gives us the number of students in that particular range of weight. So 9 students are there in the range of 31 to 35 kilograms. 14 students are there for the weight of 41 to 45 kilograms, so on and so forth. What is the class width in this case? For this, you can pick up any class and check its lower limit and upper limit difference. So the first one, if you see, the difference between 35 and 31 will be how much? 4. If you see 55 and 51 or 60 and 56, everywhere the difference is 4. So this, please make sure that we should always check whether the class width is uniform. You will understand the reason why when we discuss other things in this chapter. But first we should make sure that the class width is uniform throughout the table. Okay, so the table is good enough. Now imagine that suppose a student's weight is 35.5 kilograms. Where will you put the student, or where will you put the reading? Will you put the reading in the class of 31 to 35 or 36 to 40? Definitely not both of them. Both are not the correct places where you can put 35.5. Then thus we don't know in which class to put him. So for this, there is something called as a continuous frequency distribution table. We will have to make the classes continuous. How to do that? What is it? Let us see. Okay, let us see how to convert a discontinuous frequency distribution table into a continuous one. For this, let us observe the original class intervals given to us, that is the weights of the children. It is from 31 to 35, 36 to 40, 41 to 45 till 71 till 75. Okay. Now observe the upper limit of the previous class and the lower limit of the next class in each case. For this, you may look at 31 to 35 and 36 to 40, or 56 to 60 and 61 to 65. Any two pairs of classes you can pick up and observe. This is because we know that the class width is uniform overall. We have already observed this. Okay. Now out of these, pick up any two pairs. Let's see the first one. If we look the upper limit of the previous class and the lower limit of the next class, what is the gap between them? The gap is nothing but the difference between them. So the difference is equal to 1. This gap divided by 2 will give us 0.5. This 0.5 needs to be added to the upper limit of each class. That is, it has to be added to 35, 40, 45, 50 till 75. And the same 0.5 needs to be subtracted from the lower limit of each class. So it has to be subtracted from 31, 36, 41, 46 till 71. Okay. Now once this is done, we will get the classes as seen in the second table. So they go from 30.5 to 35.5, 35.5 till 40.5, 40.5 till 45.5. So the class width still remains uniform. Okay, it is the same throughout all the class intervals, and the upper limit of the previous class now becomes the lower limit of the next class. That means we have converted the discontinuous frequencies into continuous ones. Now coming back to our original question, where will we place the student having a weight of 35.5? For this, we have got two options, two classes, 30.5 till 35.5 and 35.5 till 40.5. Always remember, by convention, we choose the next class for putting this particular observation. So in this case, we will choose 35.5 till 40.5 to place the student having a weight of 35.5 kilograms. This procedure of converting a discontinuous class interval into a continuous one will be useful when you attempt questions in exercise 14.2 such as question number 2, 3, 4, 5, 8 and 9. You will also need this when you are attempting to solve question number 4 and 7 from exercise 14.3.